Hello everyone, I am Sumalata, your chemistry teacher. In today's class, we are going to discuss about continuation to the fifth year group elements or nitrogen family. In previous class, we have done with um, general introduction and physical trends in physical properties. Now we are seeing about chemical properties or trends in chemical properties. Before watching that, small request from my side. Just try to watch complete without skipping. Try to get more information what I am giving you. If you feel useful and informative after watching this, please do subscribe, like and share these videos to your known people. Mention your words in comment box. First one, from chemical properties, first one we are going to discuss about oxidation states. See, in oxidation states, what will come? See, first one, in fifth A group elements, all elements are showing maximum most of the cases +3, +5 and -3. +3, +5 and -3 oxidation states. +3, +5 and -3 oxidation states. Is all, that means all elements present in this group are showing all these three oxidation states or not? Let's check. If we move down the group, +5 oxidation state, stability decreases. What is the reason here? If you moving down the group, +5 oxidation state stability will be decreases. The reason behind this one is inert pair effect. What is the reason here? Inert pair effect, because of inert pair effect. What do you mean by inert pair effect? Reluctance of NS electrons to show, to involve in bond formation with other atoms. That is nothing but inert pair effect, because here while moving down the group, size will increases. If size will increases, already we know about NS electrons are completely filled here, so that the completely filled electrons, S electrons, maximum having more attractions towards the nucleus. That is the reason they are showing little bit inert nature to involve in bond formation with the other atoms, so that while going down the group, +5 oxidation stability will be decreases. But if you take bismuth, typically it will form BF5. Boron pentafluoride will form. Only this is an exception here. And coming to next one, down the group, I am not writing again here, down the group, +3 oxidation state. Oxidation state stability increases. Stability increases. What is the reason here? Here also same. With increasing size, along with size, shielding effect will also be increases. See, stability increases because size increase and shielding effect. These are the two reasons about why +3 oxidation state increases down the group. If you see -3 oxidation state, here -3 oxidation state also decreases. Stability decreases because the same reasons applicable here, whereas in the case of +5 oxidation state, here also size will increases and shielding effect. So that means not +5, +3 oxidation state reasons here also applicable, so that if size increases, shielding effect operates here, so that other electrons, it can't able to attract electrons from outer side. That's about it. Then coming to nitrogen, if you can see, nitrogen, it can show maximum possible oxidation states between +1 to +4. It will not show +5. Why? Because there is no d orbital for nitrogen. That is the reason it cannot able to show +5 oxidation state. It can show all possible oxidation states from +1 to +4 in acidic medium most of the cases. Suppose you can see one chemical reaction, 3 moles of HNO2, you can take nitrous acid, then you will get see nitric, it will form nitric acid and water, and then 2 moles of nitric oxide. Here, if you observe oxidation states of all these nitrogen containing compounds, here nitrogen having +3 oxidation state, it is +4, and it is +2 oxidation state. See, it can disproportionate in acidic medium all possible oxidation states between +1 to +4. Okay. Next, coming to phosphorus. If you can see phosphorus can show all possible oxidation states between all possible oxidation states between +5 to -3 oxidation states. +5 to -3 oxidation states in acidic and basic medium. That means alkali and acidic medium. It can able to show. Then coming to remaining, if arsenic, antimony, bismuth, if you can see, maximum most of the stable oxidation state for all these three elements is the +3 only. Coming to their covalency, if you see, covalency for nitrogen is 4 only because of non-availability of d orbitals. If you can see covalency of for remaining elements, phosphorus, arsenic, antimony and bismuth, if you can see, these are having 6. Covalency is 6. Actually their covalency is ground state level +4 only. If it is going to excited state, that will become 5. But here empty d orbital is there. That is the reason they will show covalency 6. This is about oxidation states. Then coming to anomalous property or anomalous behavior of dinitrogen. If you can see anomalous behavior of dinitrogen is the N2 molecule. It is why it is showing anomalous behavior? Because it is having small in size and high electronegativity, high ionization enthalpy and non-availability of d orbitals. These 4 properties can make nitrogen become unique when compared to the other members of that same group. So, because of non-availability of d orbital, nitrogen can't able to form d pi p pi bonds. It can't able to show d pi p pi bonds, but it can show p pi p pi bonds. It can show p pi p pi bonds. See, this one is not possible, but p pi if you observe, it can show with itself. That means if you take nitrogen, dinitrogen and triple bond, and there is p pi bond is there, I mean with itself also, along with other atoms, nothing but those are having small size and more electronegativity. Nothing but if you take carbon, oxygen, these are the non-metals and also small size and also having more electronegativity atoms. D pi p pi bonds you can observe from phosphorus onwards, because the d orbital availability is there. And p pi bonds also not observed in higher atoms, because the orbitals distributed in a large space. That is the reason p pi bonds are not formed in higher atoms. Okay, this is about oxidation states and anomalous behavior of dinitrogen. Then we can move about reactivity nature of 50A group elements towards oxygen, hydrogen, halogen and metals. So you can see about those things. See my dears, here we are discussing about reactivity towards hydrogen. First we can discuss reactivity. Is it visible? Yes. Reactivity towards hydrogen. Yes. Here 50A group elements form EH3 type hydrides. Which type of hydrides formed here? EH3 type hydrides will form. Here E is nothing but 50A group element: nitrogen, phosphorus, arsenic, antimony and bismuth. Instead of E you can write these elements. Okay, down the group, if you can see, stability of nitrides will be decreases. Stability of not nitrides, hydrides. Stability of hydrides. Stability of hydrides decreases. Stability of hydrides decreases. So reducing nature increases. Reducing nature increases. Here basic nature decreases. Basic nature or basicity decreases down the group. All these properties comes under a down the group. Here basic nature, if you can see, NH3 is more basic than, yes, NH3 is more basic than PH3 is more basic than ASH3 is more basic than SBH3. This is greater than or equal to BiH3, because these are having similar ionization enthalpy or similar electronegativity. That not ionization enthalpy, electronegativity is similar for these two atoms. That is the reason maybe greater than or equal to is applicable here. So this is about hydrides. Hydrides one more time. EH3 type hydrides formed by 50A group elements if they are going to react with hydrogen. Here E is nothing but 50A group element: nitrogen, phosphorus, arsenic, antimony. Down the group, stability of hydrides will be decreases. That means that will indicate the reducing nature will be increases down the group. So next one, basic nature will be decreases. Here basic nature also decreases. This is the basic nature of 50A group elements. You can see one more time. One more thing is what here, see, ammonia you can take. Ammonia is the mild reducing agent. Mild reducing agent. And BiH3, if you can see, this is the strong reducing agent. This is about reactivity towards the 50A group elements with hydrogen. Then coming to reactivity towards halogens. Halogens, X means halogens. Here especially EX3 and EX5 type halides will be formed. EX3 and EX5 type halides will be formed. Okay, listen, if you take EX3 type halides, nitrogen will not form EX5 type halogens because non-availability of d orbital. And one more thing here, down the group EX3 type halides stability will be increases except nitrogen trihalides. Remaining all trihalides stability will increases. If you case if you see in the case of nitrogen, NF3 only stable, NF3 only stable, this is an exceptional one. Remaining all are nitrogen trihalides are unstable, except NF3, remaining all are unstable. And if you compare EX3 type halides, NX3 except NX3, remaining all halides are stable. And if you compare except BIF3 or BIF5, BIF5, if you can see, if you compare remaining trihalides except BIF3, not BIF5, BIF3, this is except BIF3, remaining all trihalides will be covalent in nature. This is will be ionic in nature. Okay, this is about the reactivity towards halogens. If you can see, reactivity towards oxygen, reactivity towards oxygen, O2 or O, you can write oxygen. Here which type of oxides will form? E2O3 and E2O5 type oxides will be formed. One more thing, E2O5 will be more acidic when compared to the E2O3 oxides. E2O5 is the more acidic when compared to the E2O3 type oxides. Then if you go down the group, acidic nature will be decreases. You can see that trend also here. Acidic nature will be decreases. Suppose if you take E2O3 type oxides, N2O3, P2O3, next AS2O3, SB2O3 and Bi2O3. All fifth year group trioxides, if you see, then listen, these two oxides have acidic nature. These two oxides are amphoteric in nature. This oxide having basic in nature. So that means down the group basic nature will be increases, acidic nature will be decreases. This is about reactivity towards oxygen. Then coming to reactivity towards metals. Especially while react with metals, binary compounds will form. Reactivity towards metals. Okay, here especially binary compounds will be formed. At this time -3 oxidation state will be there for fifth year group elements. Binary compounds few you can see, Ca3N2, Ca3P2, next Zn2, Zn3 AS, not Zn3, Na3 AS, next Zn3 SB2, next Mg3 Bi2, Listen, what are their names? These are the binary compounds. In all these compounds, fifth year group element have -3 oxidation state. Here it is the calcium nitride. This is the calcium phosphide. And this is the sodium arsenide. This is zinc antimonide. This one is magnesium bismuthide. See, these are the binary compounds of 50A group elements, reactivity towards metal atoms. Okay, this is about chemical properties of 50A group elements. First we have discussed about oxidation states. Second one, anomalous behavior of dinitrogen, and third one, reactivity towards hydrogen, reactivity towards oxygen, reactivity towards halogen and metal atoms. I think you are understand this lecture. If you feel useful and informative, please do subscribe and share these videos to your known people. If you have any doubts, just please mention your doubts in comment box. Thanks for watching. We will meet in the next class. Bye all of you. Take care.